Okay, we're going to play a little bit with a branch of science called optics. And what I have here is a 4-inch square mirror, and I've put LED lights all around the edge. And it looks like I have two rows of LED lights, but that's already kind of what we're going to be talking about is the reflection of, we see the LED, the original LED, the actual LEDs, that meets your eye, and then it reflects off this mirror a little bit of ways down the mirror and bounces up and hits your eye again. Now, I have going to let this boot up a little bit, and I've got some lights, little display, and you can see a little bit better that the light from the LED hits the mirror and comes up and meets your eye. So it looks like I have two rows of LEDs there. Now, one of the reasons why it looks like the second LED is just a little bit in on the mirror is that's a very sharp angle that the original LED has to make. And so the angle that it hits the mirror is uh, very, very high. And a principle of optics is that the angle of incidence, which is the light hitting the mirror, equals the angle of reflection. And so it just moves these LEDs down the mirror just a little bit. Now I've made a cover for that little contraption, and what it is a kind of a partial mirror. And what will happen is that when rays hit this surface, most of the light will bounce back down to the mirror, and a small amount will go through this piece and hit your eye. And so hopefully what will happen is we'll have light rays bouncing up and down, up and down, up and down, up and down, up and down. And each time it reflects, it'll move the row of lights a little bit further in because, again, it's a very high angle of incidence. And when it reflects, that angle of reflection is going to equal the angle of incidence. So it will just appear to move the LED lights down a little bit. Now I'm going to put the cover on, but I've made it so that a person can take the cover off in case they want to use different angles and experiment a little bit. But if you can see, there's a notch right there, and then there's another notch on the cover, and I make sure that the two notches are on the same side, and that way I know that they'll fit. So we're just going to use these thumb wheel screws to screw the top down. They're made of plastic. And now let's turn it on and see what we get. Oh, looks like we've discovered a wormhole. So as you can see, what's happening is every time it reflects off the top, it moves down the mirror a little bit, and also because some of the energy goes through the top piece to meet your eye, it loses a little bit of energy. So it actually looks like there's a huge distance inside this little box. There's a green button on the other side if you want to play with the different patterns that you can make. Could be kind of fun. But that's an example of what you can do with just a plain mirror. Well, one plain mirror and one kind of special kind of mirror, and the optics of a light ray hitting a mirror and bouncing back in exactly the same angle that it hits the mirror. So if anybody's interested in playing with this and experimenting for themselves, just let me know. Be happy to send it along.